Hello and welcome to our chapter on chemical bonding. You are going to learn about ionic and covalent bonding and how to represent covalent molecules using Lewis structures and the details of their electronic structures. This chapter is also in junction with the next, where you will see the formation of covalent bonding in more detail. A chemical bond is an attractive force that keeps the atoms together in a compound. The attractive force is observed between the protons in the nucleus of the atoms and the valence electrons. Based on the arrangement of electrons and how they are used in bonding, there are three types of chemical bonds. In ionic bonds, electrons are transferred. This results in ionic compounds. In molecular compounds or covalent compounds, electrons are shared. This kind of bond is called covalent bonding. And in metals, electrons are pooled. The positive ions are islands in a sea of electrons. This kind of bonding is called metallic bonding. We are going to focus only on ionic and covalent bonding.
Chapter 9 focuses on bonding, and the one type of bonding we'll be seeing is ionic bonding. It's a type of attraction that exists between ions. Ions are formed, as you know, with the transfer of an electron from one species to another. In this example, sodium is losing an electron to chlorine. Sodium becomes a positively charged ion, a cation, and chlorine becomes a chloride ion, a negatively charged ion. These opposite charges, as you expect from Coulomb's law, they're opposite charges, they will attract each other. And they will form what we call a crystalline substance. As you see, there is no single ion pair, but it's rather a collection of many ions in a predictable order, in a predetermined order. This is what we call a crystalline substance. The ions, whatever building blocks there are organized in a long-range order. So sodium chloride, being an ionic substance, crystallizes to form the solid, and it's a crystalline solid.
You should always remember that metals lose electrons. As a result, they form cations. And nonmetals gain electrons, and they will form anions. Of course, considering the formation of ionic compounds. Sodium will lose its one valence electron to chlorine. After the loss, sodium will be left with just the core electrons, which is isoelectronic with neon, the same electron configuration of neon. And then chlorine, by taking that electron, will increase its number of 3p electrons from 5 to 6. Now it will have a complete shell and will have the electron configuration of the next noble gas, which is argon.
For most main group metals and nonmetals, we can predict the charge of the ion that will form by looking at its number of valence electrons. Remember, metals form cations. They will lose their valence electrons to become ions. For example, sodium and lithium, being in group 1a, have one valence electron. So they're going to lose one electron. Therefore, they will become a positive one charged ion, both of them. On the other hand, group 2a, beryllium, magnesium, they have two valence electrons. So these elements in group 2a will lose two electrons to become ions because they're shedding all their valence electrons. For example, magnesium is going to be a 2+ charged ion. In the case of aluminum, we can do the prediction. It has three valence electrons, It's going to lose all three, and it's going to have a positive 3 charged ion. When it comes to nonmetals, now nonmetals will gain electrons to fill their shells. For example, phosphorus has 3 unpaired electrons, so therefore it will gain 1, 2, 3 electrons to have a total of 8. We're going to see this rule as the octet rule, and because it gained 3 electrons, it will have a charge of 3 negative. Likewise, sulfur and oxygen will gain 2 to become 2 negative, and halogens, fluorine, chlorine, bromine, iodine, will gain 1 to fill their 1 unpaired electron to be negative 1 charged ions. And noble gases, since their shells are full, they won't form any ions. So we can show actually the ionic bond formation using these Lewis-Stott formulas too. If you have a calcium atom bonding with an oxygen atom, it will lose its 2 electrons to the 2 empty positions of oxygen and therefore form the calcium ion and the oxide ion.